important program which can be used as a program to illustrate a break instruction, or it will discuss a very important title called as to check whether given number is prime number. Now what exactly is a prime number? You have the mathematical definition. You can spell the mathematical definition for me. Yes, you have the definition properly, saying that a number which is divisible by 1 or by itself is said to be a prime number. That's how we discuss the entire prime number operations. Let me modify this particular number. Suppose if I have a number n, your n is said to be prime if it is divisible by only 1 and by itself. It means that it should not be divisible by any number apart from 1 to n, apart from 1 and n. So it means that the number can be called as prime even with this definition also. A number is said to be prime number if it is not divisible by any number apart from 1 and n. Apart from 1 and n, illustrate that this number can be 2 and the second last number can be n minus 1. So I'll say any number will be called as prime number if it is not divisible by a number in the range of 2 to n minus 1. Let's check out mathematically how do I say a number as prime number. Suppose if I take example of say 9. 9 will be called as prime number if it is not divisible by any number from 2 to 8, because n is now 9. So I'll divide it by 2. So I'll say 9 mod 2 equal to 0. Is 9 mod 2 equal to 0? No. So if the answer comes as no, will you say the number is prime? No, not necessarily, because it might be divisible by some more numbers in the future. So let me continue this particular operation. 9 mod 3 equal to 0. True. Yes. Now once the result says yes, in that case, is it worth to continue this particular division operation till the end? Not necessarily, because you have decided that this number is divisible by 3, hence we conclude that this number is not a prime number. So if any answer comes as yes, then we conclude that the number is not a prime number. Now let me try with one more value. Suppose if I say that I am supposed to say 7. 7, I'll divide it by 2 first. Your answer comes as no. So if the answer is no, then it might be divisible by some other number. So I'll say 7 mod 3 equal to 0. Answer is again no. 7 mod 3 equal to 0. Answer is no. Say 4. 7 mod 5 equal to 0. Answer is no. 7 mod 6 equal to 0. The answer is still no. Now here the collective answer is no, because you divided this particular 7 from what to what? 2 to 6. You started dividing from 2 to 8. So here the value of 7 is divided from 2 to 6, and at all the cases you found that the number is not divisible. Hence we conclude that this number is a prime number. So either I am supposed to go till 2 to n minus 1 or till this condition is going to be achieved. So when I say I am supposed to go from 2 to n minus 1, it is definitely a simple implementation using a for loop. So I'll say for I equals to 2, I less than equals to n minus 1, I plus plus. But in the mid, I am supposed to do this particular operation. Now here 2, 3, 4 or 2, 3, 4, 5, 6, all these numbers are generated in I. So can I say if n mod I equal to 0? The condition. So here the number is supposed to be divided by the varying values of I. If n mod I equal to 0, then if this is true, would you wish to continue or stop? I wish to stop. Hence what I'll do is I'll use a break instruction. So I'll have a break instruction. Let me use a pair of curly brackets to identify the operation in this particular program clearly. So I want to check whether number n is prime or not. Hence what I started is I started dividing this particular n from 2 to n minus 1. So that is using a for loop. Every time the value of n was divided by I checked is it divisible. If it's divisible, I'll say break. Now when I say break, so there are two ways to execute this particular loop. When 9 is given, in that case it will use a break as a termination, because 9 mod 2 equal to 0 false, 9 mod 3 equal to 0 true, break, it will take you out. But when I say 7, 7 mod 2 equal to 0 false, 7 mod 3 equal to 0 false, 7 mod 4 equal to 0, 7 mod 5 equal to 0 false, 7 mod 6 is also false. So none of the time the condition is true. It means that the break will not be terminated. In that case, it will terminate, it will take the control outside the loop using this particular condition. Now, how I quit the condition will decide whether the number is prime or not. If I quit the condition by break, if I quit the entire operation by break, it means that the condition is true. If the condition is true, it means that it is what? A prime or not prime? It is not a prime number. Good. So here, when I took 9, 9 was tested for 2, then it was tested for 3, but it was never tested for remaining numbers because 9 mod 3 equal to 0 was true. Since break will take you outside this particular loop. If I have say 7, 7 was tested for 2, tested for 3, tested for 4, tested for 5 and tested for even 6. The value of the condition n mod I equals to 0 is true. Hence it will not execute the break instruction, it will quit by the condition. So that will help us to conclude that if I quit by condition, then the number is a prime number, because in that case the collective answer is no. If I quit by break, it means that somewhere in the mid the condition has turned out as true. Now question comes, how do I decide, how do I check whether I quit the loop by the condition or quit by the loop by the break instruction? For that, what I'll do is I'll use a simple flag variable. Let's take a flag variable, say k, and set this as 0. Now k is a flag which will oscillate in this particular entire loop. It will oscillate in this particular entire loop. So whenever the loop executes, your k is having a value of 0. Now what to do is, if any time this condition is true, n mod I equal to 0 is true, in that case set k as 1 and then say break. Now check this. Outside this, I can check whether k is 1 or 0. If k equals to 1, what that indicates? If k has changed its value from 0 to 1, it means that you quit by break. If the value of k is 0, it means that the condition was never true. Hence k maintained a value as 0. So outside this particular loop, it will quit with the k value as 0 itself. So value of k is 0 if I quit by condition, and value of k is 1 if I quit by break. So here the value of k will help us to understand how we terminate this particular loop, how we have terminated the entire operation of this particular loop, whether by break or whether by the condition. So that's how we implement the prime program. Now let's see a program to check this entire task. We'll see the program to do this particular entire operation. Let me place the program. So now here I have the program for you. So I have included the header files. I have taken two variables n, I, and here I have taken flag. You can take k, you can take p, you can take m, you can take flag. I have taken an integer variable called as flag. Clear screen. Ask the user to enter the value of n or enter the number. So the value of n is entered by the user. Suppose if the user enters say 9. What is the value of flag initially? Flag is 0, n is 9. So I starts dividing from what to what? 2 to n minus 1. So first it says 9 mod 2 equal to 0. False. False since this bracket will not be executed. If part will not be executed, go back, I becomes 3. When I becomes 3, 9 mod 3 equals to 0. True. True in the sense flag is modified to 1. True, flag is 1. Break. What a break instruction does? What a break instruction does? Break, as discussed earlier, will terminate the loop. Hence, the loop in this case is what? For. So, break will transfer the control outside and flag is tested. Is flag 1? 1 equal to 0, false. False since the number is not prime. If n is 7, this will be the last case. If n is 7, how it works? The for loop starts with 2, I is 2. Initially flag is what? 0. 7 mod 2 equal to 0, false. 7 mod 3 equal to 0, false. 7 mod 4 equals to false. 7 mod 5, 7 mod 6. So when you go back, the for loop quits by the condition. If it quits by the condition, you will observe that flag is still 0. 0 equal to 0, true. True, number is prime. So for n as 7, the number is declared as prime. For n as 9, the number is not declared as prime. This is how we perform the operations of the program to check whether a given number is a prime number or not. Thank you.